Welcome to another lecture. So in this lecture we will be discussing about torsion in gastropods. So before discussing torsion, let us first see what torsion is. Okay. So what is torsion? Torsion is the rotation of visceral organs. What are the visceral organs? Visceral organs are the vital organs, okay, in the mollusk's body. So visceral organ or the visceral mass contains all the vital organs, okay, organ system. It contains all the organ system. And what's happening in torsion is there is a rotation of visceral organs on the head, foot along the axis through an angle of 180 degrees in the anti-clockwise manner. So what torsion is, it is basically rotation of the visceral organs up to 180 degrees angle and in the anti-clockwise manner. So the torsion basically takes place, or it occurs in all gastropods during their larval development. So basically it is seen that mollusks have a symmetrical body, but here in the gastropods there is, because of torsion, an asymmetrical characteristic, okay, and this is in the prosobranch. Gastropods have the order prosobranch, ofistobranch, okay. So the prosobranch has torsion and the ofistobranch undergoes torsion and then detortion. Now, as I said, mollusks are typically bilaterally symmetrical animals, and in gastropods there is asymmetrical characteristic due to detortion. Now, the torsion occurs in the free swimming bilateral symmetrical veliger larva of gastropods, okay, and it converts the larva into the adult form and it is asymmetrical. So before torsion the larva is symmetrical, but after torsion it becomes asymmetrical, and majority of the visceral organs are affected by torsion, okay. Now let us discuss the status of larva before torsion. Now the status of larva before torsion. Okay, the pre-torsional larva has bilateral symmetry, okay. The pre-torsional larva has a bilateral symmetry, which means if it is cut from one plane it gives two mirror half images, okay. The mantle cavity of larva is posterior, okay, posterior, and the ventral and the ventral cavity lies on the posterior and it is ventral in position with pallial complex before torsion in larva. The ctenidia or the gills, okay, it is for respiration, and the nephridiophore for removal of metabolic wastes. Both of these are situated on the posterior side, okay, on the posterior side. On if you do not understand what is posterior side, let me explain. Okay, in this diagram I've drawn, this is the anterior and this is the posterior. This is the head region of the mollusk, and this is the actually this is the posterior side. This is the head, this is the foot, this is the mantle cavity. So what nephridiophore and gills, they are present on the posterior side, okay. Now the alimentary canal is seen to be straight, okay. The alimentary canal or the gut is straight, so the mouth lies on the anterior and the anus lies on the posterior end, okay. Like for example, in this figure A, okay, this figure A, we see that the gut is straight, okay. This is the gut, okay, and it is straight. Now, okay, now if we talk about the auricles, okay, the auricle chamber of heart are placed behind the ventricle. You understand, auricle and ventricle? So the auricle will lie on the okay, actually the position of ventricle, okay, is on the front of auricle. So the auricle is placed behind the ventricle before torsion. Okay, and if we talk about its nervous system, okay, it is perfectly bilaterally symmetrical. Okay, now let us discuss the mechanism. Okay, so this is the figure A. Okay, let me just fold it so that it becomes easy, right? So in this we see in figure A. Okay, let's first see what are the let me just zoom it. Okay, perfect. Now here we see this gut. It is straight, right? And this is the head. Okay, this is the head, this is the mouth, this is the cerebral ganglion, this is pleural ganglion, and this is pedal ganglion. This is a right pleuroparietal connective from here to here. This one is right pleuroparietal connective, and this one will be left pleuroparietal connective. This is the gut. Okay, and this is aorta, this is heart. Okay, this is left parietal ganglion, this would be right parietal ganglion. This is left tenedium, this is right tenedium. What tenedium is? It is gills, right? Anus is present here, and this is the left renal aperture. This is the foot region, this is the head region. Yes, okay. As I said before torsion, all these organs, because before torsion the larva is said to be symmetrical. Okay, this is a symmetrical larva, right, in the gastropods. Now what happens is, now when there is the larval stage, okay, during development, what happens is, in the mental cavity the organs shift towards the right side, anti-clockwise. So the organs, they shift towards the right side. On this portion there is basically the growth, okay, active extension, okay, on one side, and retarded growth on the other side. So because of that, this portion, the visceral portion, it actually tends to shift towards the right side in the anti-clockwise manner. So we see the left parietal ganglion, which was here, right? The left parietal ganglion turns in the 90 degrees. In the 90 degrees angle, right? It comes to the right side. The anus also comes to the right side, which causes the gut or the alimentary canal to form a loop-like structure. Okay, all the right tenedium, we see right pleuroparietal connective, right? All the visceral organs, they tend to shift in the right side slowly and surely, right? So all this takes place because of the retarded growth on one side, and there is a continuous extension, we say active extension or growth on the other side. This is aorta, this is the gut. Okay, it's converting into a loop-like structure, and then this is undergoing torsion. Now in the next diagram, okay, here we see almost it is shifted to the head region. So this pleuroparietal connectives are tend to form an 8 figure. Okay, the figure 8 in maths. So okay, and all the left parietal ganglion, we see right tenedium, left renal aperture, anus, all this is shifting to the head region. Okay, we see the gills and the excretory nephridiophore shifting to the head region, and the torsion causes this loop like structure. Okay, this is the gut, and this is thrown into a loop. Okay, and in the last part of the diagram, we see that there is complete torsion that has taken place. This pleuroparietal connective has a crisscross. Okay, it is converted into the crisscross manner. And we see that there is a loss of symmetry here. Okay, now this mantle cavity, there is a diagram in the here. So what we see is the mantle cavity, which was there before torsion. It was on this posterior side. It opens on the posterior side. After the torsion, it comes to lie on the anterior side, on the head side. Okay, so this converts into this. Okay, we see the mantle cavity comes to face forward, and the tenidia and anus, they are shifted to the head region. Okay, this is the right tenidium. Okay, and it comes to lie on the head region. It comes to lie on the head region here. Okay, and the elementary canal, yes, is twisted and it forms a figure 8. So here we can see it is forming an 8 figure, right? And there is, of course, the loss of symmetry. Okay, and the torsion of the dorsal visceral mass, okay, occurs in the such like, because here we see the auricles, like we discussed before, that the auricles, they used to lie on the which side? Here. The auricle chamber of the heart are placed behind the ventricle, and what happens is, now it remains to come on the front. Okay, it comes to lie on the front, and the corresponding organs on the left side. Okay, corresponding organs on the left. Okay, what is the left? Here, all the organs on the left region here. Yeah, all the organs of this. So we can say left tenidium, you know, all the organs on the left portion tend to actually it degenerates. Basically, it either doesn't grow or there is loss of organs on the left side. Okay, now we see at the end the prosobranch is left with only unpaired kidney. Okay, and it remains with single auricles, and there is only single tenidium, which is the right tenidium. The left tenidium becomes it basically gets degenerated or doesn't grow. Okay, now let us discuss the mechanism in again. We'll just revise. So what's happening is that first in the larva, the mantle cavity and the associated parts, okay, anus, tenidia and apertures, renal apertures, all these lie on the posterior side of the body, right? Posterior side, on the posterior side. And yeah, tenidia is behind the heart. The alimentary canal is straight, okay, and the nervous system is symmetrical, right? Now during the development, the mantle cavity with its organs, okay, it will shift towards the forward towards the forward side, and there is the position comes to lie on the front of the or near the head. Okay, now this takes place because of the retarded growth. Okay, and there is an active extension on the other side. Okay, as in here we see there is retarded growth on the one side and active extension on the other side, and this shifts the pallial complex to the forward side. Now let's discuss the effect of torsion. Okay, what torsion causes? What is the effect of torsion? So okay, the mantle cavity, okay, comes to face forward. Tenidia and anus comes to the position above the head. Okay, the right pleuroparietal connective, okay, actually the pleuroparietal connective they are crisscrossing. Let me show you to make it easy. Right, here we see this right pleuroparietal connective. So these are actually the right, I'm saying it right because it is present on the right side. Okay, like here, let me explain. This is the right pleuroparietal connective and this would be the left pleuroparietal connective. So what's happening is there is crisscrossing taking place, and this is the effect of torsion. Also, the alimentary canal, it becomes twisted, forms an figure 8, or you can say a loop or a U-shaped structure. Of course, the loss of symmetry is there. Okay, now the torsion of dorsal visceral mass occurs in such a way, okay, that the right auricle of the heart and right gill, okay, they remain in their original position, but the corresponding organs on the left are usually lost. Okay, and in the prosobranchs, they are left with single kidney, tenidium and auricle. These are the effect of torsion. Okay, so let's discuss the detortion. Now detortion takes place in the ofTortion, right, and this is the reverse of torsion. Okay, now what happens in torsion is what takes place in what is the reverse of detortion. Now the pallial complex shifts in the posterior. Now earlier what happened because of torsion was the pallial complex came to lie in the forward position, but in the detorsion process it becomes reverse. Okay, it shifts back to the posterior position. The tenidia, okay, which is the gills, okay, comes to lie behind the heart, and the visceral loop of the nervus becomes untwisted. Okay, first in torsion it twists, and then in detortion it untwists. Okay, and becomes symmetrical again. Okay, and this takes place in ofTortion. Okay, gills are exposed because there was the loss of shell. Okay, it receives an external current of water for respiration, so the gills becomes exposed. Okay, and basically helps the organisms for respiration, and this process becomes easier, and there is loss of shell. However, in detortion, all the lost organs, okay, because of torsion, as I said, that there was single auricle, there was single tenidia, right, all the tenidia, auricles, kidneys, right, those were lost, are never replaced. However, they continue to have unpaired tenidium, auricles and kidneys in so the last portion of the video we will discuss the advantage and disadvantage of torsion. So the advantage of torsion would be, okay, that it improves the ventilation of mantle cavity. Okay, earlier what was happening was that the mantle cavity of mollusk, the water current, basically what we say, the respiratory current would draw from behind to forward, and because of that, this mollusk would cause the backward current, which opposes or impedes the respiratory current. Okay, it doesn't basically goes with the respiratory current, it opposes the respiratory current. Okay, when the water draws from behind to forward before torsion. After torsion, the mantle cavity comes to lie on the anterior, that is above the head. Okay, in this diagram, right? So what happens is, earlier the water current was drawing from behind to forward, right, and it would not, and it would oppose the respiratory current, it would oppose the respiratory current. Then after the torsion, okay, after torsion, the mental cavity comes to lie on the front. Okay, this and it would basically help the organism to now what will happen because of that is there would be single current. Okay, there won't be two currents. Like first it was the water current which is drawing from backward to forward, which is opposing the respiratory current, right? Now when it comes to lie on the anterior side, there would be single current. Okay, now what will happen is the current would come from forward to backward, and this would aid, this can assist the organism for locomotion as well as respiration. Okay, understood. The disadvantage would be, because since we see the tenidium, anus, okay, the nephridiophore, okay, excretory organ, it is lying on the head region, so it would likely pollute the respiratory current. Okay, and this would fall in the head region, so basically this would pollute this mouth of the organism. Okay, so these are some of the advantages and disadvantages. Okay, that's the end of the video. If you like it, please give it a thumbs up. Okay, if you think any topic was missed, you can comment in the comments, and also do not forget to subscribe to my channel. Okay, it will mean a lot to me, and thanks for watching. Take care.